This video is on special right triangles. So we have some triangles here, and they're all special. They're special for a reason. If you have a 45, 45, 90 right triangle, if we were to do the Pythagorean theorem to find the missing hypotenuse, we would do 4 squared plus 4 squared, which is 32. And the square root of 32 is going to give us 4 root 2. So then over here, we're going to have another 45, 45, 90. So if this is 6, we know this is also 6. So if we did 6 squared plus 6 squared, that would give us 72. And the square root of 72 is going to be 6 root 2. So I'm seeing a pattern already. I'm sure you are as well. If this is 11 and that's 11, without even touching the Pythagorean theorem, we could make a guess. What do you think this side is? If you said 11 root 2, you are correct. So another kind of special right triangle is a 30, 60, 90 right triangle. That's when we have a hypotenuse that is twice the length as one of the legs. So we have a 4. 2 times 4 is 8. If we did the Pythagorean theorem, that would be x squared plus 4 squared is equal to 8 squared. So x squared is going to be equal to 48. And the square root of 48 is going to be 4 root 3. So this guy's 4 root 3. Now, knowing that this is a video on special right triangles and they have patterns involved, if you were to guess that this was 5 root 3, you'd be correct. And if you were to guess that this is 6 root 3, you would be correct. So you have two kinds of special right triangles you're going to be working with. You have your 45, 45, 90s, and you have your 30, 60, 90s. Okay? That's what we're going to work on today. So your 45, 45, 90 will always have this pattern. The legs are congruent because it is isosceles, so you have leg, leg, and then you have leg root 2. The hypotenuse is always going to be whatever your legs are times the square root of 2. Now your 30, 60, 90 is always going to have a short side and a long side. And the long side is your hypotenuse, and it's going to be 2 times the length of your short side like we saw in the pattern earlier. And this side is always going to be whatever the short side is, root 3. Now, you will find other teachers, other books saying that this is like an A, and an A root 2. Some use X, X root 2. Some use S, S root 2. It doesn't matter. Whatever the letters may be, it just needs to represent part of that triangle. I always use L root 2 because L stands for legs of an isosceles triangle, and S stands for the short side of a 30, 60, 90. Whatever works for you works for me as long as you're getting the answers correct. So, we're going to find the missing sides. This first row is just 45, 45, 90s. So, this is our leg, and this is our leg root 2. If you like writing the pattern inside until you get used to it, I recommend it. So if this is 6, we know this guy's got to be 6. And this has to be 6 square roots of 2. And you're good to go. That one's done. The next example, this is your L root 2 side. So if we think about this algebraically, L root 2 is equal to 8 root 2. So if we need to solve for L, we need to divide both sides by the square root of 2. So those cancel, and L is equal to 8. Now I know you could have just looked at that and said, hey, if it's L root 2 and 8 root 2, L has to be 8. But I wanted you to see why algebraically, because it doesn't always work like that in some of these more advanced problems. So this is an L, so we know what L is equal to. L is equal to 3 root 2. But here's something tricky. Don't just say that this is 3 root 2. This is 3 root 2 just for the L. Now the root 2 is still there, so you actually have a little bit of multiplying to do. 3 root 2 root 2 is 3 root 4, because the square root of 2 times the square root of 2 is the square root of 4. And we know that the square root of 4 is 2, so that's technically equal to 3 times 2. This is actually equal to 6. So you do have to have some radical skills to do special right triangles. Okay? So here are 3 more 45, 45, 90s. I would like you to attempt them on your own. Keep in mind They are going to be a little bit tricky, but give them a try. So if my leg is 2 root 5, this guy is also 2 root 5, and this guy is 2 root 5 with the root 2 on the end of him. 2 root 5 root 2 is going to be 2 root 10, and you are good to go. Next one. Now remember I told you the radical skill. L root 2 is equal to 8. This is my L root 2 side. It is equal to 8. So you have to solve for L. So you need to divide both sides by the square root of 2. So that's going to give me L equals 8 divided by the square root of 2. You should remember you're not allowed to have a radical in the denominator, so that becomes 8 root 2 over 2. But of course, 8 divided by 2 is 4 root 2. Now, like I said, they were going to get a little bit tricky. It's not like it's a difficult concept. It's just the fact that you need to have really good radical skills to handle these efficiently. So if you are struggling a little bit with your radical skills, then you need to get a little bit of extra help and strengthen those, because 30, 60, 90, 45, 45, 90, and Pythagorean theorem are very heavily dependent on knowing how to work with radicals. Okay, next one. This is the L root 2 side again. So L root 2 is equal to 7. I know. You know you need to divide both sides by the square root of 2. So that means L is equal to 7 divided by the square root of 2, which is 7 root 2 over 2. And yeah, that's actually your final answer. There's nothing else you can do to simplify that, so you just have 7 root 2 over 2. Alrighty? Bingo, there you go. Let's talk about some 30, 60, 90s next. Now, again, I'm going to recommend that until you get good at this stuff, you put an S on the short side, you put a 2S on the hypotenuse, and you put an S root 3 on your middle side, opposite of the 60. Always be careful that you know where you're putting what. So my short side is 5. 2 times the short side is going to be 10, and the short side with a root 3 on the end of it is going to be 5 root 3, and you are good to go. That's an easy example. Now again, this is the short side with a root 3 on it. And it's very easy to see that the short side is going to be 7. And 2 times your short side is going to be 14. It's just a pattern you need to follow. But I'm going to show you that the way I did this algebraically was the short side root 3 is equal to 7 times the square root of 3. If I need to solve for S, the short side, I would divide both sides by the square root of 3, and magically they just cancel out, and S is equal to 7. But just like the last set of problems, there are difficult ones where you need to work with radicals. So I just wanted to show you what was happening so you can apply it if it comes up. 4 is your 2S side. That's my 2 times the short side. So if 2 times the short side is 4, then 2S is equal to 4, which means my short side is 2. So this is 2. That makes this 2 root 3, and we are good to go on that guy. This next one, if you said 2 and 4 because the last one was 2, 4, and 2 root 3, you'd be wrong, because this is your S root 3 side. This is actually your short side. So S is already equal to 2 root 3. So this means this guy is 4 root 3, because that's 2 times 2 root 3. This is S root 3 root 3. So 2 root 3 root 3 is 2 root 9, which is 6. So the right side's supposed to be 6. So again, it's not that it's a difficult thing, but if you have weak radical skills, it's going to be challenging. If you have very strong radical skills, it's a pretty simple concept. Okay? So here you go. Here's another row. I would like you to give these guys a try. Give them a shot. Be patient. Try to see if you can work them out. So this guy, that's your 2 times the short side, which means your short side is 4 root 2. It's half of the long side. And this is 4 root 2 for the short side with the root 3. So this guy should be 4 root 6. And that's it. This next example, this is your S root 3. So our s root 3 is equal to the number 9. If we divided both sides by the square root of 3, we would get s is equal to 9 root 3 over 3, which we can see would simplify to 3 root 3. And 3 root 3 times 2 is 6 root 3. Again, gotta have strong radical skills. S root 3 is equal to 7. Divide both sides by the square root of 7, and you get s is equal to 7 root 3 over 3. So your short side is 7 root 3 over 3. 2 times your short side would be 14 root 3 over 3, because all we did was multiply 7/3 root 3 times 2. And 7/3 times 2 is 14/3. Last one, the short side. How do you know that's the short side? Maybe this is the short side. If you do not have enough information, you just can't do the problem. So one of the things that comes up is people always assume it's 30, 60, 90, or people always assume it's 45, 45, 90. If you do not know that you have a 30 or a 60 or a 90, or if you do not know that they're 45, 45, 90, or you have an isosceles triangle, you actually do not have an information. So this one, you just don't have enough info. Now, I would rarely ever give that to you, but I wanted to point that out because sometimes it's a Pythagorean theorem problem and people just assume it's going to be 30, 60, 90. So you just have to make sure you're being very careful. Alrighty. Here's a challenge problem for you. Why don't you go ahead and pause the video and give this one a try. I'll actually show you the answer to this in just a minute. If you pause the video, there should be your minute. So, this is a 30, 60, 90 triangle over here. This is a 45, 45, 90 triangle over here. So we're looking for x and y's, but we have to work with the information we are given. So we have to start on this side. So if this is 45, 45, 90, this is my L root 2 side. So if this is L root 2, that's going to make this 8, and that's going to make that 8. But now in this side, that's 8, but we're now at a 30, 60, 90. So this L just became an S, and this would be S root 3. So x is equal to 8, and y is equal to 8 root 3. All right? Hopefully you got that. This is Longo, and I am out. See you, bye.